Now we're gonna continue with the nth root. So since any root can be written as a power, therefore the rules of powers apply to roots. Now in square roots, if we have a number under a square root times a number under a square root, we make one big root and we multiply the numbers together. So the same applies for the nth root of a times the nth root of b. We put one big nth root and we put a times b over it. Same thing for division, nth root of a over nth root of b. We can make one big nth root and a over b. Now, if we have the nth root of a raised to the power p is the same as nth root of a to the p. Now here we have a root under a root. Nth root under pth root of a, we multiply them together. Why we multiply them together? We multiply n and p and we put it under one root, which is n times b, p root. So a pth root of a, we can write it as a to the 1 over p. Nth root of this one, we can write it as 1 over n. So this root under root, we can rewrite it as a to the 1 over p, all raised to the 1 over n. Now we know from the properties of powers, when a power is raised to another power, we multiply the powers. So this is a to the 1 over np, and we can rewrite it as the root of np and a under this root. Now we have examples on multiplication. We have the cube root of 10 times the cube root of 200. We can put it under one big cube root of 10 times 200. We can rewrite this as 2 times 10 to the 3. Now, we said the cube root of 10 to the 3 is 10, and we will have 2 under the cube root, so our answer will be 10 cube root of 2. Here we have the same root. So cube root of 10 times cube root of 200, we put it under one big cube root and we multiply them. But what if we have different roots? Here we have square root, here we have cube root, and we have sixth root. So we have to find the LCM between these. When we don't have the square root, it means we can put a 2 here. Okay? So between the 2, the 3, and the 6 is the common, the LCM. So we have to find the LCM between these. Here I have 2. To make it a 6, I have to multiply by 3, and I raise this to the power 3. Here I have to multiply by 2, and here by 2, it will be x to the 4. Here it is already to the 6th root, so I leave it. Then my answer will be x to the 12 under the 6th root. Now 12 over 6 is x to the 2. Here again we have different roots. 25, I can write it as 5 to the 2 under the 4th root. Here I leave it 5 to the 5 under the 6th root, and 625 I can rewrite it as 5 to the 4 under the cube root, and the 25 I can write it as 5 squared under the 3rd root. Now I have to find the LCM between 4, 6, 3, and here 3, which is 12. So I put them all under the 12th root, and to make this a 12, I multiply this by 3, I multiply this by 2, I multiply this by 4, and this one I multiply it by 4. I simplify my answer, it will be 5 to the 2. Here we have the 7th root of 5 to the 12. The 12, I can rewrite it as 5 to the 7 times 5 to the 5. I can put it